because we couldn't meet for class because of the fire drill, I'm going to give a short lesson on some of the concepts in section 3.3, which is measures of variation. So variation is a term for the spread and consistency of the data. So we're going to look at three basic measures: range, standard deviation, and variance. The range is a simple calculation that you probably already know. It's the highest data value minus the lowest data value. It's the easiest to compute. However, if you have an outlier in your data, the range is going to be much bigger than it technically should be. Standard deviation is much more useful. Standard deviation, it can be found longhand by subtracting each data value from the mean. No, subtracting the mean from each data value, squaring those answers. That makes them all bigger and positive. It exaggerates the differences. And adding them together, dividing by 1 less than the sample size, and then taking the square root of this value. That creates the standard deviation. And although this seems like a bizarre computation, your calculator can do it in a heartbeat, and it has some wonderful properties. First of all, the standard deviation, because you took all those differences and squared them, and then added them, and then divided by something that's obviously positive, and then square rooted it, it's never negative. And the only way it could be 0 is if all the data values were exactly the same. That way the mean would be whatever that number is, and the differences between the mean and each data value would be 0. So, in general, the standard deviation is almost always a positive value. It is in the same unit as the original data, but rounded to one place beyond the original data, as we know about all the statistics we have so far. If the population is normally distributed, meaning it would fall into a bell-shaped curve, 68% of the data will be within 1 standard deviation of the mean, 95% will be within 2 standard deviations of the mean, and 99.7% will be within 3 standard deviations of the mean. And this general principle is called the empirical rule, and we're going to look at it quite frequently. So, standard deviation is obviously a unit of measure. Okay, so in my calculator I had data about the high temperature for random days in Chicago. The mean of the data was 58.55 degrees, and the standard deviation was 20.01 degrees. And I let my calculator do the computations for both of these. I just wanted to do this so that we could talk about what it means to be 1 standard deviation from the mean. Okay, so this 1 standard deviation from the mean tells me to add and subtract the standard deviation from the mean. So if the mean was 58.55 degrees and I subtract 20.01, I get 38.54 degrees. And if I take my mean, 58.55, and add 20.01, the standard deviation, I get 78.56 degrees. So if temperature in Chicago is normally distributed, then 68% of the temperatures, the high temperatures, will be between 38.54 degrees and 78.56 degrees. And what does it mean to be 2 standard deviations from the mean? It tells me to subtract and add the standard deviation twice. So 58.55, the mean, minus 2 times 20.01, and 58.55 plus 2 times 20.01. So that means that computation gave me 18.53 degrees to 98.57 degrees. So this means 95% of the high temperatures in Chicago should be between 18.53 degrees and 98.57 degrees. This particular interval, 2 standard deviations from the mean, is very important to statisticians. 2 standard deviations from the mean is where we expect to find 95% of our data values, and statisticians call the values in this interval usual. So any value outside of this interval is deemed unusual. Okay, so here's how this plays. If you ask a random person, would it be unusual to have a high temperature in Chicago that was 10 degrees? They'd probably say no. A statistician, however, would say yes. It's outside the interval of usual temperatures. Right? The interval of usual temperatures for 2 standard deviations from the mean is 18.53 degrees to 98.57 degrees. So 10 degrees is too low to be usual. One other note about standard deviation without a calculator. It's a bugaboo to compute. We can use the fact that 95% of data values are within 2 standard deviations of the mean to create a decent rough estimate of standard deviation. And this rough estimate is found using something called the range rule of thumb. Okay, so to approximate standard deviation, you could take the range and divide by 4. That would be the range is the high value minus the low value, and divide that by 4. It's crude, but it is often close to the actual standard deviation. And if I told you that in my computations the high temperature in Chicago gets up to 87.3 degrees, and the low temperature 29.0 degrees. That was in my actual data. And I subtract these. I would get 87.3 minus 29.0, getting 58.3 degrees. And I divide this by 4. I would get 1.6 approximately on the rounding. So about 14.6 degrees is the standard deviation. Okay, so let's go back. What was the standard deviation for my temperature experiment? The standard deviation was 20.01, and my range rule of thumb gave me a standard deviation of 14.6 degrees. So it's a rough estimate, doesn't do exactly the trick, but it's a lot quicker, and if someone just wants you to estimate the standard deviation, you could do that. Okay. The other thing we're going to talk about today is variance. Variance is important to statisticians. However, it will not play a big part in our statistical life outside of this chapter. Variance is the square of the standard deviation. In other words, the number right before the calculator took the square root. The most interesting thing to me about variance is that its unit is always square units. So if the data is in feet, variance is in square feet. If the data is in dollars, variance is in square dollars. Yes, that's right, square dollars. And if the data is number of eggs, then the variance is square eggs. Okay, so that should give you something to hang on to as you're reading Triola. Please do read it twice, and I will see you when next I see you.